Welcome, everyone. Thank you for joining us on today's webinar for oNote. This is Real-Time Collaborative Event Modeling with oNote. I'm Bobby Calderwood, founder of oNote. I'll be the host of this webinar today. Joining me today is Mike Shearer, who's our lead principal engineer at oNote. And we'll also have a guest cameo today from Martin Kleppmann. He is unable to join us live at the webinar today, but we pre-recorded an interview with him dealing with some of the technological and even some of the philosophical aspects of modern collaborative web software. So we'll be pleased to hear from Martin later in our meeting here. But first, I'd like to thank both Mike and Martin in absentia for joining us today. Mike, can you introduce yourself and just tell us a little bit about yourself?
Yeah, Mike, lead software engineer over here at oNote. I actually have pretty extensive history exclusively at startups, developing technologies front end and back end. I actually do have a little bit of real-time experience prior, so I'm coming into oNote to kind of lend some of my experience here.
Great, thank you, Mike. And yeah, thanks for your expertise. It'll be kind of the outline of the content today on the webinar. First, we're going to present a demo of the collaborative feature in oNote, so we'll see that kind of in action. And then a lot of today is going to be sort of a conversation between Mike and I, discussing how we went about implementing collaboration in a modern web application, what were some of the challenges, what were some of the technologies involved, and so forth. We'll hear from Martin. We'll splice in kind of that interview video that we pre-recorded with Martin Kleppmann on some of those technologies. And then towards the end of our panel discussion, we'll take audience questions as well. So we're looking forward to having you all add questions. If you are interested in submitting questions to be answered towards the end of our panel discussion, please add it to the Q&A tab in your BigMarker interface. Not the chat panel. It's just too hard for us to see all the chat going by. There is a specific place for questions and answers. We can moderate those, publish the ones that are interesting and we think will be of general value to the audience. So please submit those questions in the Q&A tab within your BigMarker interface. All right, without further ado, let's proceed to our demonstration of the collaborative feature in oNote. This is oNote. You'll notice some really awesome UI enhancements. Big thanks and shout out to Joe, who's our lead designer, and the rest of the team that put together this set of UI changes. We're really happy with how the UI is looking these days. To begin a collaboration, you must have upgraded to oNote Essential. So go ahead up to the profile and billing section of the page. You can upgrade to oNote Essential there, and that's how you'll need to do that prior to initiating a collaboration session. Now, anyone can join a collaboration session. Even oNote starter users who are free users can join a collaboration session, but only oNote Essential users can initiate a collaboration session. So to start a collaboration, we go to the left-hand menu, click Start a Collaboration. There we go. We start our collaboration here. And now we're in the collaboration menu. You notice that some elements of the left-hand nav change when we initiate a collaboration session. Get rid of Cash's face down here. The most important thing to do now is to invite participants to this collaboration session. So we click the invite participants. We're shown this modal window. Here's the collaboration session URL. This is the join URL that you can email out or send via Slack or whatever to your collaborators. I'll send this to Mike so he can join the session here.
And here we go.
So now Mike has joined our session, and now we can collaborate. So we can continue to edit the event model just as we normally would. And drag things around, you see things jumping around that Mike is changing on his end, certainly adding and moving and changing the location of our elements here. We've been running this with fairly large groups during our enterprise pilots. We are running pilots with teams who are interested in event modeling. Please reach out to us if you're interested in such a pilot. We've been running collaborations remotely with teams as large as 20 people engaged in this real-time collaborative mode, and it's worked great. We're really pleased with the technology and how it's shaken out here. After the collaboration session, so a couple of notes about a collaboration. There's a host of a collaboration, and then there are participants in the collaboration session or guests. Having started the collaboration session, I'm the host. So this is, we create a new collaboration area here. That's this Pizza Tracker demo collaboration. That is distinct from the model on which the collaboration session is based. We started the collaboration session from this Pizza Tracker demo model. But now we're in kind of a sandboxed area off to the side where we're just collaborating with each other. It's kind of a scratch area where we can collaborate with each other. Guests can contribute to this collaboration sessions, but they don't have the underlying model, natively on their local instance of oNote within their browser. They're only able to access this model by way of this collaboration session. Once we've become satisfied with the state of this collaboration, I can end the collaboration session. And the changes from our scratch area are then merged back into the source model. So all the changes that we've made to the model end up back in our source Pizza Tracker model, and our browser, the host's browser, is automatically redirected back to this source model. So that can be a little confusing for first-time users, but there is a carved off kind of scratch area where we do the collaboration work, and then that model is merged back into our source model here, this Pizza Tracker demo model. Great. So that's how the technology works. If you upgrade to oNote Essential today, you can initiate those collaboration sessions and then send that URL, the collaboration join URL, to any of your team members, whether they're oNote Essential users or just oNote Starter users. Yep. So actually, let me just focus on our cameras here. There we go. So Mike, we just seen this technology. It seems like magic to me because, collaboration's hard. It's a hard problem to solve. Trying to get, browsers to communicate over, unknown network topologies, and it feels like magic to me. I'm really pleased with how this feature turned out. How did you and the team make this work? How did we make real-time collaboration work in oNote, and how can other modern web applications, maybe the apps that our participants, our webinar attendees today are building, how can they add collaborative capabilities to their own web apps?
Yeah, I think that anybody looking to do this really just has to, take various approaches depending on what they're trying to deliver to their users. In the past, I've done things like live stream chat where, old school stuff like HTTP long polling was totally fine. We've done WebSocket apps in the past, which are great, but it's still kind of a centralized model. Like we do use WebSockets heavily here, but it's not really the core of this collaboration feature. It's interesting. There's a lot of newer technologies out there. WebRTC, quite notable. Definitely a lot of potential there.
Yeah. And that's for the communication bit, for actually getting the browsers to talk. Yep.
Yeah, so it kind of depends on a lot on like what you're really trying to accomplish for your users. Bobby had this idea that was pretty foreign to me from most startups I've worked at, of having it be a little bit more decentralized as far as the way the browsers communicate. So I'd say our approach is pretty unique that way.
Yeah, so there's kind of two halves of this problem that our team tackled. There's sort of the half that Mike talked about, which is how do you even get the connectivity to work? How do you get it so that individual users on individual browsers can communicate with one another, and share changes back and forth. And there's a lot of techniques there. WebSockets, Mike talked about, HTTP long polling back in the old days. Now we've got WebRTC. That's kind of how things can collaborate and communicate with each other. But then the other really tricky bit of that is how do you maintain state? How do you maintain two different data structures, this event model, on two different machines or n different machines if you've got a lot of participants in this collaboration system? How do you keep them all synchronized? And there's a couple different techniques for doing that. The technique that underlies technologies like Google Docs, Google Sheets, kind of the Google suite of Office software. That's all in browser, and that's using a technology that sort of combines the communication protocol bits that we just discussed with the state management bits, and that's a technique called operational transform, or OT. So that's kind of it's tried and tested. It's battle hardened. There's a lot of good technology built on it, like Google Docs. It's an amazing piece of technology, but that does sort of conflate the communication piece and the state management piece, and all of those things have to be centralized. All of those changes have to stream to the server, where they're given a total order and then streamed back out to all the participants. So that's kind of how Google Docs and other technologies have approached this problem. As Mike alluded, the oNote team, we took a bit of a different, more decentralized approach. So we used a couple different communication bits and then a different technology distinct from OT for our state management bits. Can you talk a little bit more about that, Mike?
Yeah, and it's kind of a unique idea for compared to any place I've been before. In the past, like Bobby mentioned, any projects I'd worked on, it was always this idea of the server being kind of the arbiter between these things. There's definitely some latency downsides to that. It is easy to think about that. You've got this server that's your central source of truth for everything, but it's a lot of extra steps. Bobby had pulled up some research and looked at some ideas on using CRDTs, which are conflict-free replicated data types, for actually doing real-time merging in a more decentralized manner. And actually, the interesting thing is that this merging's happening on the browser side for the host. So in our example, Bobby being the host, as I'm sending my patches of what I've changed up to Bobby, that algorithm's actually correcting and merging in those changes in real time in Bobby's browser directly. So it's actually not even touching the server at that point. It's quite quick. The algorithm itself isn't designed to be the fastest thing on the planet, but it is very nice compared to having all the network latency overhead of a centralized server that you're basically passing through, validating, doing security checks on, everything. Had experience with it in the past, and while the idea seems really simple, that you have this centralized source of truth, the security vulnerability pieces of it and the complexity actually gets pretty high by the time you have a really nice implementation.
Yeah, and for a smaller startup like us, there were sort of two concerns that we had with OT. One of them that Mike's alluded to here is there's just latency, right? Every time you want to communicate a change, you've got to linearize it via the server and then broadcast it back out to everyone. That incurs certainly a latency cost, but also incurs an operational overhead, frankly, for a small startup, right? Google's got teams of SREs, and they keep their infrastructure up all the time, and they're able to monitor all this stuff, and we just didn't have a big enough team that we felt to incur that kind of operational overhead for a feature like collaboration. These newer techniques involving CRDT is lower operational overhead because everything happens, as Mike said, in the browser and not on the server. We're actually not sending anything related to model changes over any oNote managed infrastructure. That's all directly peer-to-peer from browser to browser via WebRTC. So that's how we communicate, is via WebRTC, and the state management algorithms that Mike talked about are CRDT, which allows us all to see the same model, even as we're all slinging changes around at each other. Everyone ends up with the same set of changes because they're resolving those changes locally within the browser using these techniques around CRDT. So it's a fascinating set of technologies. It's got some really nice side effects also around data ownership. So because all those changes don't have to go over our servers, the user stays in control of their data. Right? The host of this collaboration session owns the model. It lives in their browser. They don't have to ask us for permission. They don't have to send any of that data to us. They just send it directly to their participants and the people they want to share the data with. So it's got some nice data ownership and data privacy side effects and benefits as well. Let's actually head over to Martin now. Martin, I interviewed some time ago and had a really interesting and wide-ranging conversation with him about this technology that he had written an awesome paper on this particular class of CRDT, which we ended up implementing as a part of oNote to get this real-time collaboration benefit. So let's hear from Martin. I asked him some questions in this video. He gives some really great answers. So stay tuned for Martin, and then we'll come back with Mike and I will kind of finish the discussion of the technologies and comment on what Martin said, and then we'll be happy to take some questions from the audience. Thank you for joining us, Martin. It's great to have you.
Hi, Bobby. Great to be here.
Absolutely. Yep. It's good to hear your voice. And your research obviously has been very influential on the event streaming community, which I know a lot of our audience is interested in, as well as certainly recently on the CRDT and local first applications, real-time collaborative systems. It's an active area of research, and some of your research has been very interesting and, as we'll discuss a little bit later, very influential on oNote. So we're grateful to have you here with us.
Yeah, well, I love what you're doing with oNote as well. I've been fascinated with the idea of event sourcing, like just as a design philosophy for quite a while now. So I've been taking that idea and trying to apply it in different areas as well.
Thank you. Thank you. Yeah, your talk, turning the database, or your article, excuse me, turning the database inside out with SAMHSA was very influential on my sort of event sourcing journey, 6-7 years ago, whenever that article came out. And it's interesting to have come full circle back around to some of your more recent work in CRDT as I was building the collaboration feature here in oNote. So it was interesting to have you bookending oNote a little bit with your work. So, so what is drawing you towards this world of real-time collaborative systems? What's interesting or challenging about CRDT and local first applications? Some of the things you've written about recently.
Well, what I'm working on in this area is really trying to give users a bit more control over the applications that they use and their data inside them. I feel like cloud software, say like Google Docs and things like that, is great. It's incredibly convenient. You don't have to email files back and forth anymore. You can just have multiple people log in and change stuff, and it just works. But it comes at the cost of Google owning all of your data, and the primary copy of all of your data is on Google servers. And you temporarily get access to that if Google wants to let you have that. And I feel that's just like quite a bad regression in terms of the control that we had. Like, back in the 90s, if you had some data stored on your local hard disk on your computer, then it was yours, and you knew that it would remain there, and you can back it up, and you can be sure that no, Google isn't going to come along claiming that you violated their terms of service and suddenly log you out of the data. So what I've been trying to do is have that same convenience of cloud software where you can have real-time collaboration, all of that, but at the same time, the user control over their own data, where you have a copy of it on your hard drive and you know that it's there and nobody can take that away from you. And that's a philosophy we've been calling local first software. The local being like you want to use the local computing, the local hard drive, the local network as much as possible. Cloud services are fine. I'm not saying we shouldn't use cloud services, but they should be like an optional extra that make the software better. They shouldn't be the controllers of all of our data.
Yeah, and that philosophy, very interesting. I read the article, is fascinating. And sort of unbeknownst to me, I didn't set out to do this, but ended up making oNote as sort of a local first application, sort of backed into it on accident a little bit. But
brilliant.
There's some really interesting, both ethical and philosophical questions and concerns sort of wrapped up in local first, as well as technical ones, right? There's sort of the two sides of it, the human part of it and the technology part of it. I think the human part of it's fascinating and very important. We'll probably have to leave that aside because it's a short interview and sort of dig into the more technical parts, but I really do appreciate, in a very Tron-like way, fighting for the user. I think that's an important voice. So I heard Joe Armstrong, Erlang's creator, give a really interesting talk about that several years ago about what if we had, clouds that were built into our physical infrastructure, our roof panels and other aspects of our physical infrastructure would be data storage devices, would be part of sort of a shared cloud, but they'd also be closer to us and more within our physical control. It was an interesting talk.
Yeah, he had many interesting ideas.
So what's required from a technology standpoint to make an application that is local first, but still has this collaborative, I feel like I'm in touch with all of the other folks and we're not emailing files around and so forth?
Yeah, well, that's where CRTs come in. So CRTs are a set of data structures that you can use in order to build this kind of local first software. And the principle is really that like each user, the data that each user has got on their computer will constitute some kind of documents. And it doesn't really matter. This could be text documents, or it could be spreadsheets, or it could be graphics, or it could be an oNote, like collection of boxes connected with arrows. And all of those are valid documents. And a user may update their document, and they might update the document while they're disconnected from the internet because the coffee shop Wi-Fi isn't working, for example. And so this means that you are mutating your local copy of some data. And later, when you get your internet connection back, you want to synchronize that data with other people. And those other people may have themselves made changes to their local copies of the data. And so what you now have is these two versions of the document that have diverged somewhat. They've become slightly inconsistent, and we want to merge them back together into a consistent state in such a way that we don't discard anybody's edits. So we want to make sure that all the changes are preserved, but at the same time, everyone ends up in the same state. And this is exactly what CRDTs do. So they are, if you model your application around CRDT data structures, then the effect is that each user can update their own copy of it, and the CRDT takes care of the merging of any concurrent edits that have been made to this data.
Yeah, so that reminds me of several sort of long-standing problems in computer science. Offline sync, which you mentioned, right?
Mm-hmm.
You know, for areas with poor or no connectivity, how do you access your Google Docs when you're in an offline mode? And then version control, obviously, will be familiar sort of use case to software engineers. It's sometimes said that when software engineers make systems for themselves, they do it the right way, and they build it as sort of this self-contained history thing that, you know, that has time as first-class construct and allows for concurrent edits. When we make
exactly
systems for other people, we just store everything in a database.
Yeah, and like with anyone who's used Git, for example, will be familiar with this concept that, like, even if you just make some local edits and local commits on your machine, you're creating a branch essentially. And then when you want to merge with somebody else's, you either have a merge commit or you have to do some kind of rebasing. And in the merge commit, you may have to resolve conflicts. And well, with Git, that conflict resolution is a manual process where, well, actually it's semi-automatic, because if I change the top few lines in a file and you change the bottom few lines, there's enough space that Git will just happily merge those automatically. So it's got these bunch of heuristics around this. And CRDTs kind of take it to the extreme of merge everything automatically. As a result, like, you might sometimes have a merged outcome that wasn't exactly what you were expecting, but then you can still fix it up by hand using subsequent edits.
Yes, and critically, everyone will resolve that conflict in the same way, so that everyone converges to the same doc. That's kind of the C in CRDT is the converging, or sometimes people talk about commutative replicated data types, but that convergence is really the important aspect, making sure that everyone ends up with the same document at the end. Yep.
Exactly.
How does this apply to real-time communication? So some of the discussion, or some of the use cases you've brought up, are more gradual, you know, types of changes like version control or offline sync. What about like real-time communication where things are coming fast and thick, kind of that Google Docs collaborative editing use case? How do CRTs fit in there?
Well, from my point of view as like a distributed systems theorist, real-time collaboration is exactly the same. It's just at lower latency. So you can still have several people concurrently updating this data. It's just that this data synchronization happens within 200 milliseconds rather than a day. So the degree of divergence you get will be smaller because people simply can't type that fast. And so you'll just have a little bit of divergence between the different users, and then it gets merged together. So you never end up in a situation where significant conflicts arise. But, you know, you could still imagine, like, I drag a card on to one position and you can currently drag it to another position. And so we do have a conflict in this case, even though it's a very small scale one. And it is something that the application will have to resolve. Like, either the card is going to be in this position or in that position, but it won't be in both.
Yes, absolutely. It's not Schrodinger's card, Schrodinger's command.
Yes.
So within a CRDT, it sounds like we have to have sort of a history or a log of the changes that are made. That sounds awful familiar to us event sourcing crowd. How is, you know, can you compare and contrast? How's CRDT similar to event sourcing? How's it different from event sourcing?
Yeah, so there are two main families of CRDTs, state-based and operation-based. And operation-based are the ones that look quite similar to event sourcing. What a CRDT calls an operation is what event sourcing would call an event. That is, it's like an immutable little piece of data that describes some state change, essentially. And with event sourcing, these events are something that you design explicitly. They represent something occurring in a business, typically. With CRDTs, the operations that you generate tend to be more like a side effect of some updates that happen to some data. So think of CRDTs more like kind of an object-oriented model where you've got a stateful object and you can change its properties. And whenever you do some changes to the properties, that's a state change. That state change gets captured as an operation or multiple operations. And those operations then get sent over the network to anyone else who has a copy of this document open.
Yeah.
And the key thing that a CRDT does now is that they ensure that even if different users apply these operations in a different order, they will still converge to the same state. And so the mathematical way how this is done is called through commutativity. And so that is the process for taking an operation and applying it to some state it's a commutative function, which means that you can, if I have an operation A and you have an operation B, and I apply A first and then B second, you apply B first and A second, we will both end up in the same final state. And the CRDT is very carefully designed in such a way that you get that kind of commutativity.
Interesting. So the log of operations would be more like a SQL database commit log or something like that, where it's low level, it's data domain descriptive rather than business domain descriptive, but still we're concerned with storing the history and deriving our current view of state from the history. And CRDT has these very sophisticated techniques you described for ensuring that in whatever order you see these operations, you always end up with the same read model, which is interesting, and I think could be broadly applicable within sort of the event sourcing community, but would be more difficult at sort of this higher level composite business events rather than the data domain events.
Yes, I'm still hoping to one day find a good way of joining up the event sourcing and CRDT worlds, because they feel like so similar in many ways, but at the same time, the design philosophy behind them is still quite distinct. Mm-hmm. And I would love to have something like, for example, a way of specifying something like a read model for a CRDT, so that your source can be a simple data structure, and then you can derive multiple views onto that from it. And that's something that should be possible. And we can probably take some inspiration from databases and materialized views and so on to actually implement that kind of thing.
Yeah, that's really, really interesting. It was a paper of yours that you wrote about offsets. It was your offsets paper, you and co-authors, that we actually used in oNote. So we needed this capability in oNote. We wanted to be able to collaborate in real time, which, as you said, is sort of this low latency, high frequency kind of exchange of these operations. And then we also wanted to have a repository service where after the workshop is done and you've got a baseline design, during implementation, during operations, you can gradually and in an evolutionary way sort of change the event model, but do so in a way that, like version control, you know what has happened in the past, and you can rewind to a moment in the past, or you can tag particular versions to map to what's in production and so forth. So we wanted to satisfy both of these use cases, and we came across your offsets paper, and it seemed to fit that bill. So we ended up implementing that paper in Clojure. So we wrote it in Clojure. It's written in such a way, CLJC files, I call them, that it can compile to Clojure JVM to run on the server side. So that will host the repository service, et cetera. But also compiling to Clojure script so that it can run in the browser to broker and facilitate that real-time collaboration during the collaboration session, which is sort of the subject of our webinar today. So it's been great. It was very easy to implement. We got kind of a working baseline version in like less than a week, and then we added a few other things as we went. We have released this library. It's called Converge. We've released it as Apache 2 open source. It's on our GitHub page. We'll include a link there as well. But thank you for that. It was really great to have a coherent mathematical model, because I can't create that from first principles. Like, I'm just not a good enough computer scientist to do that. But having your paper was very clear. It was very easy to take the math and sort of transcribe it to Clojure code, and it just sort of worked after a couple of days of tinkering with it. And it was sort of shocking how easy it was to like get something that worked.
I'm so pleased to hear that. You know, as a researcher, part of the reason why I write papers, rather than just code, I write code as well. But a paper can potentially describe ideas in a way that can inform lots of different implementations. And so this is what I love to see exactly, is just people taking their ideas and running with it and building useful applications, build useful software around it. So that's really great to hear.
Yeah, event modeling is not unlike a paper relative to code, right? It's higher level, descriptive of many different possible implementations, which is part of the reason it's useful. So I'm glad we have these other communication mechanisms, academic papers, rigorous models that we can use to sort of describe software to each other, because it would have been really hard to build, to port that from AutoMerge and JavaScript code back into Clojure, something that'll run on the server side. So having your paper was brilliant. That was really great. So thank you for that.
Yeah, I'm glad you found it useful.
All right. Well, thank you, Martin, for joining us today. And we look forward to interacting in the future. Maybe we can bring these two communities together, the event sourcing community and the CRDT community, and learn from each other and continue to inform the way we work.
Absolutely. Let's do that.
Thank you. Big thanks to Martin Kleppmann, again, who is not present with us today, but who very generously and kindly met with me and recorded that interview. Brilliant person. If you get a chance to read anything that he's written, articles, academic papers, really, really a fantastic computer scientist and researcher, communicates his ideas very clearly. Also just a very good person. He's very kind, very generous with his time. So a big thanks to him. We mentioned a couple of things in that chat that I don't want to miss. So we, the team behind oNote, have released this CRDT library. It's a Clojure library that, again, runs Clojure JVM on the server side, as well as Clojure script on the client side. It's called Converge. Turns out it was not as easy as poor naive me in the past when I recorded that with Martin had assumed. We actually did have a working implementation, and it worked pretty good early on. But then the devil's always in the details. We really had to do a lot more testing and a little bit more development to be in a place where we're really comfortable with Converge and confident in its maintenance of state. We can talk about that a little bit, Mike. I have just posted that GitHub link to the Converge repo in the public chat. So if you're interested in that, you can take a look. Another library that is worth mentioning here is AutoMerge. That's the reference implementation of Martin's paper that he referred to sort of obliquely towards the end of that interview. He talked about how he writes code as well as papers. The code in this case is AutoMerge. It's a really interesting library. We did look at AutoMerge as an opportunity to save ourselves from having to build our own CRDT and just using something that existed in the community. It didn't meet all of our use cases, especially the server side bit. It just wasn't suitable for our needs. But it's a very well done library. One other library that is worth mentioning in this connection, and maybe Mike, you can talk about this from some of your research, is a library called YJS. This is also another JavaScript CRDT library, primarily used in browser, but certainly can be used, like in Node.js on the server side or whatever. But YJS is also a very well-designed implementation of CRDTs that has plugins with various different communication channels and things, WebSockets and WebRTC and others. So if you're going to build a system like this for state management, it's hard to beat CRDTs, and there's some really great libraries in the community for making that job simpler and being able to use well-tested software, right? Any thoughts on those libraries, Mike? I know you looked into those recently.
Yeah, and keep in mind, I'm not an expert on this. We've dove into CRDT as we've needed to, develop this product to get collaboration working. But it's actually been pretty interesting to follow the community. Both AutoMerge, YJS, both really well written and have some great documentation to go with them. But what's interesting is you'll find, through Reddit and other threads where it kind of seems like YJS will implement something for performance and some of the changes move back and forth. So there's actually a lot of collaboration between, the two libraries. Somebody does one thing, another person kind of redirects those changes back in. So, the field is still developing and there's a lot of information share, which is super cool to see. But yeah, like the interface is a little bit different. It kind of depends on, what you're trying to implement as to which one, would be the great way to go with. But they do seem to learn from each other, which is always cool to see in open source software.
Yeah. Yeah. YJS in particular has published a set of, or the team behind YJS has published a set of CRDT book benchmarks that are now, something of a standard within this community for how fast is my CRDT? One of the things that you inevitably trade off between just raw in-memory data structures versus a CRDT is complexity in time and space, right? You're storing the whole history of all the changes that have ever been made. So you're taking up more space in terms of memory, and then you're processing over those changes in order to compute the current state of the data structure. So you get some complexity in time. So there is a performance penalty that you pay by adopting a CRDT versus just an in-memory data structure, because a CRDT is much more like a little database than it is just like an object or something, a pointer, a reference in memory. So the YJS team has put together the set of benchmarks to try to challenge the community to step up the performance game and make these things as performant as possible. So some great work's done there. That's, caused AutoMerge and other libraries to really take a look at performance and start kind of digging in on that. Mike, you and I were interested in this performance question, and actually, again, very quickly, over the course of a couple of days, built essentially a port of Converge that we had written in Clojure over to Rust, just to see, right? How much faster is the core algorithm in Rust, right? It doesn't have the same interface and things, but the core algorithm was in Rust, and I think that's a rich area of potential for performance enhancements if we compile that to WebAssembly or whatever.
Yeah, I mean, right now Converge is great, and it's definitely no CRDT should strive to just be fast. Obviously, the correctness is much more important. We haven't really had any internal struggles with the speed ever. Like, that's never been the thing. Anytime we were having a problem with speed to the user experience, it was actually a problem with correctness. Things getting lost, and so that should be the most important thing. But what's nice about our distributed model, where the host is resolving changes and directly via Converge, is that it kind of does give infinite horizontal scalability. So however many people we have working on the project or browsers connected, right? Like we're leveraging that automatically and scaling. So
that's right.
If it ever does become a performance bottleneck with larger companies, like Bobby mentioned, going to something like WebAssembly may be a great route, at least for the client side. The server side implementation is plenty fast and when it compiles down to Java. But yeah, one of the most unique things about Converge is that versus some other newer fledgling CRDT libraries I've seen start come up in alternative languages, is that the interface on Converge is exactly the same if you're a Clojurist as just the state atom, which is a common immutable data structure abstraction. So as a developer, without going too far into the algorithmic side, you could take Converge and just run with it like you could with any sort of atom implementation. Yeah. If you're not actually looking at the change log, you don't even need to know about some of the other features available. You could just treat it as normal immutable state updates, and the library kind of handles the rest, and it's got a nice interface over the top of it for that.
Yeah, and that was one of our design constraints that disqualified a number of really good libraries like YJS and AutoMerge, is that we wanted something that felt natively idiomatically Clojurist and something that could just drop into regular Clojure code and look and feel and behave the same way that normal closure state maintenance is done, using atoms and swap and reset and adding watches and all that stuff that you do to a closure atom. So that was part of our constraint. I'm really happy with how the sort of developer experience aspect of Converge turned out. The other, and the thing that you sort of alluded to, Mike, is, when you're dealing with CRDT, there's sort of the memory and space concern. There's kind of the latency of computing the current state of the CRDT value. But almost always those things are dominated by network IO, right? Because it's just slow to send things over the network. So, you spend 2% of your time, recomputing the value of the CRDT, and 98% of your time just schlepping things over the network. We'd be remiss if we didn't mention sort of the network connectivity piece that we're using. Great library. I just dropped it into the public chat called Peer.js. This was brilliant for us. This really, really helped us go fast on this. In an early iteration of the collaboration feature, we tried to roll this piece of it ourselves, and it's really challenging. Specifically, what this is it's the WebRTC connectivity negotiation or signaling service. So when you have a peer-to-peer service, you always need a little server-side piece or something else out of band. You can send these things via email, I suppose, but you need something out of band that will allow each peer to communicate to the other peers. Here's how you talk to me. Here's my IP address. Here's what I'm capable of doing in terms of data types and sharing and all of that. So doing that kind of signaling handshake is really challenging, and if you don't do it right, like we didn't the first time around, it just becomes a real headache for doing this. So that we have two server-side pieces. Neither of these server-side pieces ever sees user data. One server-side piece is managing the life cycle of a collaboration session. Host starts it, guests join it, guests leave it, host ends the session, right? So that life cycle is managed by a server-side piece, because when you show back up to the system, we have to maintain who all the participants are and so forth. And then the other server-side piece is the Peer.js cloud service, which is their server-side free signaling servers. So they have a server-side piece that they host for free, which is great. We really appreciate them doing that. We encourage you to donate to Peer.js if you're using their service. And then there's the client-side piece in Peer.js that allows you to, it wraps the local browser WebRTC APIs and allows, instant communication peer-to-peer between browsers. So Peer.js is great. It solved a lot of the problems for us, so we didn't have to really think about the WebRTC pieces too much. We just had to figure out, what messages to send in order to synchronize these CRDTs and facilitate collaboration. Any thoughts on that, Mike, before we take a couple of audience questions?
No, let's check and see what questions we've got.
Okay. There's a question here around, do participants get to keep a copy of the model after their collaboration session? And then sort of a related question is, any plans for facilitating, model sharing and a more gradual asynchronous process of communication rather than a live kind of collaboration session, having something more like Git, so forth. To answer that, no, guests temporarily get a copy of their of the model for the collaboration session, and they can edit it, and all that state is maintained locally. But when the host ends the session, that data is deleted from the guest's machines. So the host maintains that as their own model. So that's how that works. We recognize that there is a need for the ability for multiple users to have a copy of the model on their machine and to be able to facilitate, sharing those changes asynchronously. We have a feature that Mike is working on very hard right now around a server-side repository in oNote. Right now, everything in oNote is done client-side. You're storing these things in your browser in IndexedDB. But being able to synchronize your model state with a GitHub repository and be able to push changes to that repository, being able to merge pull requests and so forth, and having the models merge changes as well. That's something we've been working really hard on and carefully designing. Mike's done some really fantastic work using Converge, using that same CRDT library to create that repository experience. Let's see.
Question from Adam, I think.
Oh, yeah. Is Peer.js the reason there are no more of the connection issues on oNote? Yes. So Peer.js really, really helped us break through some of the connectivity bottlenecks that we had early on in collaboration. By going to Pure.js, we basically rewrote the whole synchronization protocol. It's very efficient now. We only send very small patches over the network, and that peer-to-peer connectivity is working a lot better. There's still hiccups. Peer-to-peer and WebRTC is fraught. It's hard because you have sort of unknown network topologies. There's all kinds of workarounds with stun and turn servers and things. But out of the box, it works really well. We're very happy with it.
There's the question, Tobias. Outside from technical stuff, can you talk about your experience with collaboration, collaborative event modeling with teams?
Yeah. So yeah, we've done this with teams, again, as large as 20 people remotely, and it works very well. People are able to connect, share their changes very, very efficiently. We've done some technical work to make sure that there aren't partitions or bifurcations in the set of participants where people are working on one version of a model and then there's a large diff. So changes are synchronized well with those groups, and it just seems to work. We're really pleased with that. When facilitating a group session, there are far more social dynamics and issues than there are technical at this point in oNote, right? It's about making sure everyone participates and feels comfortable participating, and making sure you're sort of drawing the best out of the group. But those things are social and not necessarily technical. Yeah, it's important to make sure everyone feels like they can contribute and doesn't feel like they're going to make a mistake or be subject to censure or whatever. We do recommend having another channel open, like Zoom or something where you can have voice and video going in addition to your collaboration session in oNote, so that you can speak and communicate. So that's out of band. We didn't want to build that into oNote. It doesn't make any sense to do that. So yeah, do have that as well. We recommend that you have business stakeholders, UI UX stakeholders, and technical software architects and developers and so forth in the group. It's really important to have all those voices in there. If you just have software folks, there's no guarantee you're building the right thing and building it in a way that customers are going to want to use it. So you really do need your business stakeholders and subject matter experts, as well as your UI UX team, involved in the conversation during these modeling workshops. Does that answer your question, Tobias? Good. It looks like we are at time. Looks like we're also out of questions, which is great. So thank you so much for joining us. Please do upgrade to oNote Essential. Try out collaboration. This is a feature that we're thrilled with. Adam designed event modeling to be collaborative. This is about building a system together and having a shared language for collaborating and designing a system together. So please do use our collaboration system. Let us know your thoughts and experiences. We'd love to hear from you, our loyal customer base. And we appreciate you all for being oNote users, for coming on this journey with us. And we will see you on our next webinar. Thank you very much.
Thanks for having us.
Yes, thanks, Mike. Really appreciate you.